Hey everyone, and welcome to API Summit. This is the KongMesh update and roadmap session. My name is John Harris. I'm the principal PM for KongMesh.
Hi, and I'm Charly Molter, the engineering manager for KongMesh.
So in this session, we're going to cover three main topics. We're going to look at the exciting new Mesh Manager and Connect functionality that we announced today. We're going to highlight some of the features that we have been working on in 2023, and we're going to look at the roadmap for 2024. So, as you may have seen with the keynote earlier today, we are really excited to announce the general availability of Mesh Manager and Connect. With this release, we are bringing the power to centrally create and manage all of your KongMesh global control planes to Connect. We've also integrated our existing RBAC system with Connect, allowing users to leverage their Connect access tokens to interact with KongMesh via kubectl, including the creation and modification of policies and inspecting mesh and data plane health insights. Now, I'm going to hand over to Charly, and he's going to show us about how it works.
Hi, in this demo, we're going to show how we can use Connect to deploy a global control plane on what we call Mesh in Connect. It's going to be very easy. So the first thing is, just like Runtime Manager, I can create a global control plane. It's got a name. So here, I'm going to call it demo CP, and a CP for a demo. I'm going to add a little description and then a set of labels. So for example, onv right? I save it, I create it. This CP is now empty, right? Because we have no zones, nothing has been created yet. So the first thing we're going to go about is to connect a zone to the CP. Okay, so this zone is going to be a K3D cluster, so a Kubernetes cluster that I have running locally. And so I'm just going to call it local. So here we have all the instructions and different options to actually create this Kubernetes, to create the zone, to run the zone control plane on top of this Kubernetes cluster. So for example, the first step is always like create a mesh, create a namespace, right? Then I'm not going to do that because I already have the Helm chart. Then we're going to create a secret, right? The secret actually contains a token that will enable the zone control plane to actually authenticate with Connect, which will run the global control plane. Then we have a values YAML file. Right? In this values YAML file, we say that the control plane is running as a zone, right? That the name of the zone is local, that the KDS address is this, that we have a CP ID, that is this, and then we reference the token which is created, and then we have an egress and egress. Okay, cool. Now we Helm install it. Okay, so this is going to take a bit of time. Okay, it's running. If we look at it, and pause that at KongMesh system. Okay, we see the control plane is running and the egress and ingress are just about to start. Okay, so if we see here, that's it. The zone is connected. We just said it. The zone local is connected. Cool. So it's there. We can actually see it actually exchanged a bunch of things, which is good. And then we can access the config here, which is very good. And if you actually go back to the zone, right, you can see the ingresses and the egresses quite easily. Okay, so very cool. So now I have my mesh default, and I have nothing running at the moment, right? Because obviously it's just there. Prior to running the demo, what I do need to do is to actually configure my kubectl to be able to connect to the global control plane, right? So for this, I went into the global control plane action and did configure kubectl, right? You'll need to have a connect access token to do this, and I won't cover that, but there's plenty of documentations of that on docs.konghq.com. Okay, cool. So I do that. There's no specific version of kubectl that is required for this. It just works with the stock kubectl that you already have for KongMesh. Okay, I've got my my control plane running. So for example, I can get zones. Okay, local is there, right? I can do get meshes, right? And if I were to create a mesh, right, my second mesh, and I do kuma cuddle apply dash f mesh.yaml, get meshes, right, they show up here. And here, if we actually go to the mesh pages, we can see that my second mesh is actually there. Very cool, isn't it? Okay, so now we're in our default mesh. We're not running anything. So I'm going to run the demo. So here I do kumacuddle install demo, and I'm going to do without gateway because I don't actually need it. And I'm going to do kubectl apply dash f dash. Okay, we've got something running. Okay, so if we do git cattle pods dash and kuma demo to actually see what's up in the demo, and I don't do a typo, we actually see that the pods are starting up. Okay, so now we have a pod running here. So here we can start. We see we've got services that are there already. This is in our global control plane again. We've got the services that are there, and it's actually working. Okay, so now we've got this. Okay, so we have a control plane, we have a data plane running behind the service, right? If we look at this data plane, right, there's data planes here, and I can select it, right? And what we're going to do here is pretty cool. We're actually going to look at the XDS configuration of this data plane. Here it is. This is the data plane that is actually running on my Kubernetes cluster locally, right? There is no external connection. There is only KDS that enables you to do that. So from there, you can easily troubleshoot precisely what's happening in your different zones from Connect. This is pretty cool, right? I've got stats, I've got clusters, all kind of cool things. And this is only the start of what we're building with a service mesh in Connect. I hope I convinced you that this is pretty cool. And I'm looking forward for you to try it and give us feedback.
Thanks, Charlie. That definitely does look pretty cool. So I mentioned that we're currently integrated with Connect orgs and teams, and very shortly we'll be releasing our integrations with some of the other Connect services. This is going to include our existing Kongmesh RBAC logs to Connect's main audit sync. We're going to make our mesh services discoverable in the new version of Service Hub in Connect, and we're also going to be integrating our gateways with Gateway Manager. So let's take a look at some of the other key highlights we've delivered in Kongmesh this year. Observability is one of the main drivers we see in our customers and users for adopting a service mesh. And Kongmesh has historically supported a number of different formats and connectors for metrics, logs, and traces such as Datadog, Zipkin, Prometheus, and many others. And in Kongmesh 2.2, we released support for open telemetry formats and standards. This means that users can now use OTel for all of their observability needs. In this next demo, Charlie's going to take us through configuring a few export targets using the new OTel policy options.
In this demo, we're going to show the support of Kongmesh of OpenTelemetry. OpenTelemetry is an effort to build a standard set of APIs to actually publish and collect metrics. We're going to show here how you can run an OpenTelemetry collector in your cluster to actually pull all the data that Kongmesh can create. Okay, so it's very simple. We're running this OpenTelemetry collector. This actually comes straight from the OTel website. And we have a configuration that is a little special, right? So we scrape the stats from Kubernetes, right? From the pods, from the data planes running in Kubernetes, the usual Kuma SD config that you are familiar with, right? Then we process, we batch it, right? And we export them to Grafana, Datadog, and Honeycomb, right? You can see it here in these exporters. So we're going to send trace, metrics, and logs to all three services, Grafana, Honeycomb, and Datadog. Okay, cool. Now, if we get to our workload, we're running our workload in Connect because it's just so easy to run zones on Connect. The workload's very simple. There's a fake client that is going to create fake load. And then there's 4 different services. Fake client is going to talk to service 0, service 0 is going to talk to service 1, and then service 1 is going to talk to service 2 first, and then to service 3. Okay, cool. If we look at that, we can see all this is set up pretty well. It all seems to work. Okay, so let's get it. We've got this running for a little bit. I'm going to start with Grafana. Okay, so Grafana, we can see we've got metrics coming in, which is pretty cool. Metrics, good start. Next one, we are actually going to look at logs. Okay, what about logs? Right, we're going to take the OLTP collector. Ta-da-da-da, we've got access logs. Very cool. And now I'm actually going to go to traces. Sample trace. And we're going to pick fake client as a service name. Okay, we got a trace. What does this trace look like? Well, it looks pretty complete. Exactly what I said. Fake client talks to service 0. Service 0 talks to service 1. Service 1 talks to service 2. And to service 3, right? Okay, cool. All good. That sounds fun. So we just showed Grafana's got metrics, logs, and traces. Okay, next up, Datadog. Datadog, we already have some stuff. Let's start with metrics. Metrics Explorer. I'm going to put Envoy downstream HTTP. Well, we've got it. Somebody, and we're going to do Kumaro.io. Kumaro.io service, right? Okay, so here we've got metrics. Okay, logs now. Search. Well, we've got our logs again. It's there. Okay, very last goal. Traces. We've got the trace here. Right, it's working as well. Very cool. Okay, so this is it about Grafana. Works well. So we've got traces, we've got logs, and we've got metrics. Okay, cool. Okay, so now it's time for Honeycomb. Honeycomb, we can already see here, we've got metrics here. We're going to do group by Kuma.io service as well, as usual. Right, we've got our same metrics. Very cool. Okay, cool. What's next? Now, how about we actually look at traces a little? We need to pick the service up there. And here we can see, ta-da, we've got traces. Excellent, right? Now, very last thing, let's try to get the logs. Okay, here we got the logs. Okay, cool. Now let's look under the hood. What have we done? Our collectors like that. What have you done? What have we done with telemetry? Right? This is the mesh configuration. As you can see, this is very simple. Metrics work the same way as usual. You only say skip MTLS. Mesh trace, you just use the backend, open telemetry, and you point to your collector, right? And mesh access load, backend is open telemetry, and you point to your collector. This is that simple. It wasn't very hard to implement, and it shows the power of open telemetry, because while you might not want to publish to multiple places, you might want to build reusable things that you can easily plug with things. And the fact that Kuma supports open telemetry completely actually enables you all these great integration.
Thanks, Charlie. So another big effort that started in the community and we've adopted in Kong Mesh is Gateway API and Gamma. So Gateway API is the standard in the Kubernetes community for defining ingress behavior. And we are maintainers of Gateway API at Kong and have support for all its latest versions in Kong and Kong Mesh. In addition to Gateway API support, in our built-in mesh gateways, In 2.3 of Kong Mesh, we've also added beta support for the Gamma initiative, which is Gateway API for mesh management and administration. And this enables users to configure mesh routing and policies with standardized upstream formats. Over to Charlie again to give us a quick rundown on how it works.
Recently in Kuma, we've added support for Gamma. Gamma is part of the Gateway API spec, and it means to try to build an abstraction around service meshes to make a unified API, just like Gateway API already does it for gateways. Okay, so we're going to follow this demo, and I've already run the setup.sh to actually save some time. What this does is actually install the Gateway API CRDs, install a control plane with Gateway API enabled, right? Wait for things, and then install the demo and adapt it so that it looks just like a regular Kubernetes API. Nothing specific to Kuma here, except that sidecars are injected. Okay, so if we go there and we start by doing a port forward, we can go there and see, well, we have this application that shows, and it's actually showing two versions because there's two different versions of this API running. There is the backend v0 without the cells thing, and backend v1 with the cells thing. Okay, cool. So now we're going to have fun, and we're going to try to apply a Gateway API route for that. So let's start by looking at this route. Okay, we define two services, right? Backend v0 that will only route to v0, right? And backend v1 will only route to version v1. What is important to see here is that these are just regular Kubernetes services, right? For HTTP route, which is the Gateway API CRD, we're going to create this one that says whenever you're talking to the backend service, we're actually going to route all the traffic to backend v0. That means that we'll never see the backend v1 again. So the backend v1 was the one with the cells. We're going to kubectl apply Gamma route, right? Okay, here it is. We just installed it. So now let's look at it. What happens here? So now we can see it's never showing on cells. Okay, how about we edit this route to actually say that the weight on both backends is going to be 1, right? So we're going to get about 50% on each side. Okay. If I port forward again. Okay. New, old, new, old, old, new, right? There's a bit of randomness here, but that's the idea. And then we can go even fully the other way by saying, well, actually, now I don't want service v0 at all. Like the backend v0, I don't want to show it at all, right? And I still need to port forward. And here it is. It's always on cell. Okay. So this is what we've done in this demo. We've actually demonstrated that you can do routing policies by solely using Gateway API. All the routes. You've never been exposed to anything specific to Kuma.
Thanks, Charlie. That looks cool. Rate limiting has often been a key security-related feature for our users when they're trying to adopt service mesh. And they're really excited about applying that both in Gateway and Mesh. And we've historically supported local rate limiting, so this is per Envoy proxy. But recently, we introduced support for a global rate limiting service in Kong Mesh across the environment. It's pretty technical, so to go into the detail, here's Charlie again.
In this demo, we're going to showcase how we can use Kong Mesh global rate limiting feature to achieve two zones doing exactly the same thing. This could be a setup, for example, where you have two identical clusters that do get load, right? But you want to rate limit globally some service because they depend on a shared downstream database, right? So this is the kind of setup we're going to do. We have a first zone here and second zone, and we share the redis between each zone, but they each run a rate limit service. Okay, cool. So first example, we can see here that for each zone, we have a service that replies to it. If we actually look at our thing, we have two services that run. We have a gateway, and this gateway is going to send all the traffic to the server. There is no cross-zone traffic, just to keep things simple here, right? So we have a policy, which is a mesh global rate limits policy, and we're going to say that traffic going to this service, right, should be rate limited if we exceed 140 requests per minute. Okay, that's a little over 2 requests per second. And when we rate limit, we actually return a status 43. Okay, cool. To demonstrate that, we're going to use a performance testing tool, which is called K6. And in this tool, we're going to actually have 2 clients for 2 minutes. We're going to run from 0 clients to 2 in 30 seconds, then from 2 to 4 in 15 seconds, then stay constant at 4 for 2 minutes, and then go down to 2 progressively, right? What do these clients do? They're going to send 1 request per second, and they will randomly send from one zone to the other. It's a uniform distribution, so both zones should get roughly the same number of requests, right? And what we expect is to see the rate limit kick in at some point. Okay, the test has started running, right? And we can look at these checks, right? The checks are actually going to be green if we're actually rate limiting in zone 1, right? And for this one in zone 2. So here we can see we still have 1 client per second, right? 1 request per second. So we're obviously not rate limiting because we're only going to rate limit at a little over 2 requests per second. Okay, so here we raise up, right? And we're actually going to go increase the request rate to try to get to 3 requests per second. Okay. So for the moment, everything's going well. We haven't exceeded the budget. Okay, now we're entering 4 requests per second, right? 4 requests per second. We can quite expect rate limiting to kick in at some point. Okay. Look at this. There's a failure rate. Okay, here we can see we actually are rate limiting here. We're rate limiting here as well, right? Okay, that's good. Okay, once we have budget again, we actually resume sending requests. Okay, request is successful, right? And if we wait, as we're staying at 4 requests per second, what's going to happen is we're eventually going to run out of budget again and rate limit. Right, here we are, we're rate limiting it again. Right, so here we are. We showcase that the only thing we're sharing here is Redis, and we managed to do global rate limiting on 2 mirrored infrastructure. This can be very useful for failover, for multi-zoning, and other setups like that, which is pretty common in most modern architecture. This was very easy by using cold mesh, leveraging Connect for running the global control plane. This is what the power of cold mesh as a service mesh provides you. It adapts to your infrastructure rather than you needing to adapt to your service mesh.
All right, that's all the techie stuff out the way. Onto Openshift certification. So many of our customers are running on Openshift clusters, and over the last few months, our partner team here at Kong has been working super hard to certify Kong Mesh to run on Openshift Kubernetes clusters. We're pleased to announce that this is completed, and Kong Mesh is now searchable in the Openshift image catalog with enhanced secure defaults and custom configuration if you're running Openshift deployments. Okay, now let's take a look forward to 2024 and just a quick look at some of the features that we're excited to work on in the next 12 months. So an increasing number of our customers are using Kafka in their meshes, and we're looking at bringing first-class discovery support and traffic manipulation to Kafka to Kong Mesh. We also see a lot of serverless use cases. Lambda, Google Cloud Run, many others, Azure functions. Kong Mesh supports calling out to serverless functions today, but we definitely like to improve the discoverability and security of these connections in both directions for our customers. We're going to be working on that. And we've also going to be developing and releasing a Kong Mesh operator to assist users with lifecycle management of their installations and meshes within their clusters. This is going to be a super important part of our strategy for Mesh Manager and Connect to open up additional management use cases there. And then finally, we're working on some very exciting new observability exploration tooling for Kong Mesh. This will be both on-prem and in Connect. We have some big plans around visualization of observability data and the ways that we can allow users to troubleshoot and analyze their environments. So definitely stay tuned in this space.
And as usual, Kuma lives things through its community. You can see us on Slack. You can attend our office hours, and obviously you can always open issues and pull requests on our repos. Thank you very much.
Thanks a lot for listening, folks, and we look forward to taking any questions you may have in the comments.